Okay. In the previous section, we've been discussing about decisions. In this section, we'll be discussing about loops, which is also a control flow. We'd be using loops whenever we want to do a certain task repetitively. For example, the while loop is one of the type of loops in Python, and this loop is actually executed whenever a certain condition is actually true. If it's never true, then it's going to never execute it. So as long as the situation is true, it's going to keep on executing it. This way, loops could be divided into two. The first one is the infinite loop, and the other one is a finite loop. So an infinite loop is a loop which goes on running because the situation or the condition never becomes false. While a finite loop is a loop that runs for a certain amount of time and then it stops. So, for example, here, while loop is given which counts number until the point that the number is actually 5. So while using while loop, the things that you need to be very aware is always you need to initialize your variable that is used in the loop, and you also need to update the value of that variable so that the loop is not going infinite. Maybe let's go ahead and try coding this. So count equals to 0, it starts from 0, and then while count is less than or equals to 5, then we say print, maybe let's just print the count itself. If we run this code, you can see that it's an infinite loop. It keeps on printing 0 forever and ever. This is what we call infinite loop. It never stops. Let me stop the loop. And this is because the count has always been 0. But if I go ahead and give count to be updated, then everything is going to be okay. So uh, count plus equals 1. I believe you remember this, uh, what it means. The count plus equals is actually count is equals to count plus 1. So now if I run this code and everything is going perfectly, it prints 0, 1, 2, 3, 4, and 5. In this while loop, you can see that it keeps on updating the value of count. It prints the value of count before it actually updates. Okay, let's do one more example for these to understand the concept more crystally. Let's do a while loop that can add up numbers between 1 to 5, just instead of just printing them. Let's say count um, equals to 0. Um, Maybe we can just say it I, which is the count value, and let's say the sum, that's also 0. So while I is less or equals to 5, then we print, no, we add the value of I into sum, which necessarily means sum equals to sum plus I. And then we update I plus equals to 1, which necessarily means the same thing as I is equals to I plus 1. So later, let's go ahead and print sum. So sum is 15. How was it actually done inside of the code? Let's see a bit in detail using some explanations. So look, in the first situation, maybe let's write the value of I and also trace the value of sum. Originally, when the program started, I was 0. and then it goes to the loop. This situation is true, so it goes passing to the next one. It's going to add sum plus equals to I. Sum is 0 and I is 0. So when it adds up 1, 0 on sum is going to remain to be 0. And then I will be updated. So I is equals to was 0. When you add 1 to it, it's going to be 1. And it comes back again to the loop to check if I is actually less than or equals to 5, which is true. It goes to the loop and it adds I to sum. I is now 1. So 0 plus 1. Originally sum was 0. As it adds 1, it's going to be 1. And it now updates again I to be I plus 1, which is going to be 2 because previously it was 1. It goes again to check the loop. I is less than or equals to 5. I is 2, which is true. It's going to add 1 to whatever sum was previously. So now I is 2, and when it adds I to sum, that's 2 plus 1, that's going to be 3. And for the next one, in the iteration, I is now 2, and it's going to add 1 to it. It's going to be 3. It's going to check in the loop. It's true. So sum plus I is going to be 3 plus 3, and that's going to be 6. And for the next iteration, now I was 3 and it's going to be 4 because 1 was added. When it comes back to the loop, that's I plus, that's true because it's 4. 4 plus whatever the value of sum was previously, that's 4 plus 6. That's going to be 10. And in the next iteration, before the next iteration, I would be updated by 1. That's going to be 5. It goes again to the loop to check if this is true. So I less than or equals to 5. That's correct. And it's going to add I to sum. I is now 5. And 5 plus 10, that's going to be 15. So it goes again updating I is now 6 because 1 was added to it. It tries to goes in the loop, but necessarily it's false because it's 6. I is 6 and it's going to make this situation false. So it never goes to the loop, but to the next statement. So the final value for I is going to be 15. Okay, so this is the way that a loop works internally, and you should be very aware of it. The other type of loops is the for loop. So the for loop is most importantly used whenever you have a sequence that you not need to iterate with. So for loops are important in sequence, and we usually use it with the function range. Maybe let's go ahead and try working with for loops. So just before that, the range function is a function that has three arguments that you're going to use. The first one is, let's say, 0. It's a starting point. And let's say the next one is 10. And that's the end point. It's going to go between 0 to 10. And the last value that I'm going to give it is going to be the step value from starting the first starting from the first one. It's going to start from 0 and it goes until 10 by step value of 2. What I actually mean by this is so the value range starts from 0 and ends at 2 with a step of 2. That means 0, and it adds 2 to it. That's going to be the next value 2, and the next value is going to be 4, and the next value is going to be 6, and the next value is going to be 8. and it doesn't really actually include the boundary condition, the last value of the last value in the range. Maybe one more example, 0 to 9 with a step value of, if I say 5, then it's going to be 0. When I add 5 to it, it's going to be 5. The next value is going to be 10, and it doesn't have any, so it's going to be only 0 and 5. So the range function is very important thing that we use very usually. So if you don't actually add any step value, by default, it's going to be considered to be 1. So one for loop example that we can do is for I in range, we can say 0 to 10. So this is a sequence of number that's range is a sequence of number that's from 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It doesn't really include 10. So I would be holding each value in the sequence accordingly. So if I go ahead and print the value of I, it's going to be as follows. It printed all the values starting off 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It doesn't really include 10 because boundary conditions are not considered. So the way it works is as follows. So you see the range function that says 0 to 10 is actually holding sequence of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I would be holding a value in the iteration. First, it's going to go to the first sequence, and it's going to uh, implement the code inside of the loop, whatever the code you have written inside of the loop. And then it goes on implementing, changing I to be 1, and next is going to be changing I to be 2, next is going to be changing I to be 3, and it goes on until the last value in the sequence. Okay. One thing that I haven't probably mentioned is indentation. So indentation is something that's very important when it comes to uh, programming in Python. So it's going to cause you a syntax error if the indentation is not actually correct. For both the decisions and loops. So you see that this goes a bit of four spaces inside indented. So which makes it uh, indented, and whatever written inside here executed based on the statement in the loop. So make sure that your indentation is correct so that your code is also running correctly, because in Python indentation is not optional, but it's mandatory that you do it. So break, continue, and pass statement. These are statements that you use very often, and very important to use them in most of the cases. So break statement would break our loop, even if it doesn't complete, uh, due to a certain condition getting satisfied. So for example, here, if num is equals to 5, it's going to break the loop. Which means it's never going to run anything after 5. But for continue statements, what it does is if num is equals to 5, then it continues, which means it's going to jump these specific portion of the loop, and it's going to go running for the next one. The other one is a pass. We use pass actually not only on for loop, but also in functions, class definition, and many more. Uh, this is a way that we can just define a certain function, loop, or anything, if statement, and then we'd like to write the definition of those functions a bit later. We're not sure to write what we want, or maybe we're just going to stay until we write other part of the code. So in that case, you just say pass, and then it's never a syntax error. But if you just define the top head of a loop, like a for loop that you can see here, and if you don't write pass or don't write any statement, then it's going to cause you an error. Let's try each of them. So let's use a for loop for I in range um, 0 to 7, and then we're going to uh, use the break statement. So if I is equals to 5, then we're going to break. Okay, but until that point, we would like to print I. So you see that it's been printing 0, 1, 2, 3, 4, and when it reached on the point 5, it printed it, but then um, it it did break the loop. So if I bring in the print statement to be after this, then it doesn't even print 5 because uh, it passed that iteration. It stops before it can print 5. So if I do continue, look, it prints 0, 1, 2, 3. It jumps 5 because when it's 5, it just continues. It jumps that point, and then it goes printing 6, which is the last value. 7 is not included because boundary conditions are not considered in range function. And maybe you created another for loop for I in range. Maybe you just say 0 to 23, and then you're not sure what to do with it. So you just say pass, and that's perfectly okay. It doesn't cause any error. But if I remove pass, then it's going to cause an error. You can see that. Okay, go ahead and try this challenge, and then we'd be doing it together. Okay, let's do it together. Write a for loop that prints each character of a string in INFNOVA technologies. So by itself, strings are necessarily um, a sequence of values. So let's say name, and that name is INFNOVA technologies, and then we would like to use for I in name. So now INFNOVA technologies, each characters has been passed to the for loop, and then I print out I. So you see that it prints out INFNOVA technologies. Each letter one after the other. Maybe if you'd like to print everything in one line, because it's printing it again and again, and then it's going into a different line. If you'd like to see it in the same line, you're going to say int is equals to uh, just a string with no character. Then it's going to bring out the next line into the previous one. It keeps on connecting it to make it uh, visible like this. If I put in a space here, then it's going to put a space in between. If I put in an asterisk instead of a space, then it's going to put an asterisk in between each iteration of writing it. The next question is write a loop that prints only even numbers between 1 and 10 using continue. So if for I in range, it goes between 0 to 10, and we would like to consider only the even numbers. So if the way that you can check if it's even or odd is using modulus operator. So if I modulus 2, which is if it's even, then it's going to be actually 0, the modulus operation. If it's not even, then it's never 0. So if it's not equals to 0, then it's odd. And if it's odd, you want to continue. Otherwise, we would be printing the value of I. So that's going to be 0, 2, 4, 6, and 8. So go ahead and try these questions. Then we'll be doing it together.